All right, today we're jumping into a really cool new research paper that tackles a huge question. How do we get our AI systems to learn faster and smarter, without just throwing more and more computing power at the problem? The answer is pretty brilliant. Let's get into it.
So this is the fundamental question right now, isn't it? We all want more powerful AI, but the way we've been doing it for years, well, it has a major problem.
For a long time, the main strategy has been just brute force. You basically make the AI try a task over and over again. When it gets a tiny bit closer to the right answer, you give it a little reward. This whole process is called reinforcement learning.
And when I say over and over, I am not exaggerating. Some of these methods can require more than 24,000 individual attempts to learn a single task. The researchers call these attempts rollouts.
Yeah, just so we're all on the same page, a rollout is one single try. Just one. I mean, can you imagine having to take a test 24,000 times just to figure out the answers? That's the kind of scale we're talking about here.
And right there, that's the core issue. This brute force method is a massive bottleneck for AI development. It eats up a ridiculous amount of time, a ton of computing power, and that all translates to a whole lot of money. You just have to think. There's got to be a better way.
And that is exactly where this new paper comes in. It introduces a totally different, much smarter approach, and it's called GEPA. Now this is the perfect way to understand the difference. The old way, reinforcement learning, is like taking that test 24,000 times, hoping you eventually memorize the answers. But the GEPA way is how a smart student would do it. You take the test once, you get real feedback on what you got wrong, you actually reflect on your mistakes, and then you change your approach to ace it the next time. It's about learning, not just grinding.
So here's the secret sauce. GEPA uses natural language, the very thing that makes these models so powerful, to teach them how to get better. So instead of just getting a thumbs up or a thumbs down score, the AI gets feedback in plain English, it thinks about it, and then it literally rewrites its own instructions for the next try.
Okay, so that sounds awesome, but how does it actually work under the hood? Let's break down the engine.
It's really this elegant three-step loop. First, GEPA tries out a bunch of different instructions, or prompts, to solve a problem. Step 2, and this is the magic part, another AI looks at how well those prompts did, figures out what didn't work, and then writes out suggestions for how to do better in English. And then third, this system is smart enough to pick the most promising new ideas to try in the next go-around.
This middle step has a super cool name, reflective mutation. It's basically the AI holding up a mirror, looking at its own performance, diagnosing its own problems, and then writing a better game plan for itself. It's automated self-improvement, which is just wild to think about.
And that final step uses this really clever idea called Pareto-based selection. The easiest way to think about it is this. Instead of going all in on what looks like the one best answer right now, which could be a dead end, GEPA keeps a whole portfolio of different good strategies. That diversity is so important because it stops the AI from getting stuck in a rut.
Okay, so the theory sounds incredible and makes perfect sense. But the billion-dollar question is, does it actually work? Let's look at the data.
I mean, this is what it all comes down to, right? Can an AI that actually thinks about its mistakes beat one that just grinds through thousands and thousands of attempts? The answer from the paper is a huge, resounding yes. Just look at this table. You've got GPA going head-to-head with other methods on some really tough tasks. And it's not just winning, it's completely dominating. On Hotpot QA, for instance, it's scoring over 62, while the old brute force method, GRPO, is stuck way down at 43.
Let's just pause and break these numbers down because they're pretty mind-blowing. We're talking up to 20% better performance than the old-school reinforcement learning. And it does that with up to 35 times fewer attempts. So it's not just better, it's insanely more efficient. And this slide shows you what that improvement actually looks like. It's not abstract. On the left, you've got the simple, kind of vague starting prompt. And on the right, that's the super detailed, sophisticated set of instructions GEPA wrote for itself. It learned to add context to warn against common mistakes. I mean, it's not just a better prompt, it's a whole new strategy guide.
So we've got way better performance with way fewer tries. But believe it or not, there's actually another huge efficiency win here.
Get this, the prompts that GEPA creates are not only better, they can be over 9 times shorter than the ones from other methods. And shorter prompts mean faster processing and lower costs every single time you use the AI. It's a win-win.
So let's zoom out for a second. What's the big picture? Why does an efficient training method like this matter so much?
The researchers really nailed it in their conclusion. This isn't just a cool lab experiment. Using language to reflect and learn is a real, scalable strategy for building AI in the real world, especially for people or companies that don't have a bottomless budget.
So what this really means is that building powerful, smart, customized AI could get a whole lot cheaper, a whole lot faster, and a whole lot more accessible to everybody. It's a huge step towards democratizing AI, and it brings us closer to AIs that learn in a way that feels, well, a lot more human.
And that kind of leaves us with this final, massive question. We've just seen an AI that can teach itself to be better by thinking about its failures. If that's what's possible today, what will they be capable of learning tomorrow?
If you found this breakdown as fascinating as I did, and you want more deep dives into the tech and the papers that are shaping our world, make sure you go check out the Vibe Docs channel on YouTube. Thanks for tuning in.